In this problem, we need to prove that 1 minus omega plus omega squared whole raised to the power of 3 is equals to 1 plus omega minus omega squared whole raised to the power of 3, provided 1 omega and omega square are cube roots of unity. Now, before proving that, let me state two facts. We have 1 omega and omega square. These are the cube roots of unity. So it follows that if we take their sum, the sum of the roots is always equals to 0, and the product of the roots, which is 1 times omega squared, so that gives us omega cube, that is equals to 1. So we'll use these two properties to prove this expression. So let's begin. So here we'll start from, let's say we'll start from the left hand side. So here we are given 1 minus omega plus omega squared raised to the power of 3. Now 1 minus omega plus omega squared, we can rewrite it as 1 plus omega squared. But since we have negative omega, so we'll subtract 2 omega from it and raise it to the power of 3. In doing so, we have the sum of the roots 1 plus omega squared, which goes to 0. So that leaves us with negative 2 omega cubed. Now, negative 2 omega whole cube. So this is negative 8 omega cube, and omega cube, which is the product of the roots, that's equals to 1. So our left hand side is giving us the value negative 8. Now let's begin with the right hand side. Now on the right hand side, we have 1 plus omega minus omega squared raised to the power of 3, which can be also rewritten as 1 plus omega squared. But since we have negative omega squared, we will subtract 2 omega squared from it. Now 1 plus omega squared, that goes to 0, which leaves us with negative 2 omega squared raised to the power of 3, which is equals to negative 8. Now we have omega squared raised to the power of 3, which is also omega cube raised to the power of 2. Means exactly the same thing that's been done. So that omega cube, we know that value is equals to 1, which leaves us with negative 8 times 1 squared, and 1 squared is simply 1. We have negative 8. So I clearly see that the left hand side is giving us a value of negative 8 and the right hand side is giving us a value of negative 8. Now that means these two expressions are equal. So let's write it down. Thus, left hand side is equals to the right hand side. So that proves our problem, and both of them have a value of negative 8.